Okay, with me today at the 2550 100 Solution Fest is Dan Leonard, CTO and Associate Dean at Chapman University, and Justin Lutsky, Post-Production Engineer. Dan, tell me about Chapman University.
Hello. So Chapman University is a small liberal arts college based in Orange, California, and I'm CTO of the Dodge College of Film and Media Arts, which is a film school in digital arts and PR and advertising, broadcast journalism, and we're currently ranked number 7 in the nation by The Hollywood Reporter. We have one of the most advanced and intricate workflows in film schools in the nation, and we pride ourselves on being sort of on the bleeding edge of technology.
Thanks, Dan. And Justin, what were you hoping to see here at the Solution Fest?
Sure. I was hoping to see more tools and technology to allow me to better support our student filmmakers in collaboration. Filmmaking today is all about collaboration and sharing massive amounts of data. We're acquiring imagery at incredible resolutions, and every day we're just the data rates are going up and up. So to be able to make a film means sharing that type of data between artists and filmmakers, as fast as possible, to have everybody working on the same collective vision. So I was hoping to see tools that make that easier and faster to facilitate, so the artists can focus on the creative vision and the technology can operate seamlessly without them even realizing it, basically.
So Justin, you give me some numbers.
Sure. So pretty much the standard for film finishing these days is 4K, and an uncompressed 4K image sequence is about 1,200 megabytes a second. If you're doing 3D, that doubles. If you're doing VR, where you have multiple 4K fields of view, it just goes up and up and up. But I use basically 1.2 gigabyte per second sort of baseline for a standard 2K, standard 4K 2D image as a finishing master. And then when we have 15 stations with students each working on a different film, that's a lot of data to push through in real time. Yeah.
Okay. So Dan, tell me about some of the applications where you see the need for higher bandwidth networks like 25 gig.
Well, I think really, as Justin was mentioning, 4K is the holy grail. Up until last year, sort of the finishing was in 2K DPX, which was maybe 300 megabytes a second. So 4K increases that 4 times, and so the film industry in general has adopted 4K for origination, and just this year is making the transition to 4K post. So the tools have gotten more able to handle that. Whenever you get to that level of data and multiple streams, you run into a bandwidth problem. Sometimes the problem is solved by compression, which is lowering the band rate but trading off some of the image quality for that. But filmmakers and artists want to have the highest possible quality that they can, and so our job is always to try to push the bar to get the most bandwidth to do the least amount of compression. So what we're doing this year is looking to do 4K finishing. Just this year, Amazon and Netflix started requiring filmmakers in the industry to deliver 4K masters, and so we're preparing our students to be ready for that. That creates a bottleneck because, particularly in an educational environment, we have, at Dodge College, 1,500 students. So, regular feature film, you might have one film that's being moved. They might need to have only a few stations that are able to move that data. When you start looking at TV or education, now you have many more projects happening simultaneous, which means more people working inside a single facility, which means a greater amount of bandwidth and collaboration that needs to happen. And that's really what we're looking at these solutions for, is how can we get more streams, more people working at the highest possible resolution.
So Justin, I know you guys use a fiber channel SAN. Do you see any need for Ethernet-based storage in the future? Maybe object storage or something like that?
Yeah, certainly. So our fiber channel SAN is great for online work. But there's also tremendous archival needs we have. There's also tremendous need to push finished projects between buildings to different pools of storage, where it's not a real-time playback situation, but it is a file transfer situation. So each student short film could take up tens of terabytes of data that needs to be backed up to an external drive at the end of a project, or the student's own storage, or to a nearline storage or archival storage that we maintain. So tons of application for high-speed file transfer of massive files that are hundreds of gigabytes, if not terabytes, of data per project times however many students we have. Certainly need for that between our buildings and different workstations all over campus and that kind of a thing, for sure.
Okay, I can add to that. So at Dodge College, we have 3 distinct buildings. So we have our film building, which was built in 2006, and then in 2014 we added our digital arts building, which is across the street. And so one of the visions of our educational facility is that it needs to appear to the students as if it's one facility. And so high-speed interconnect between the buildings is vital. At the time they were building it, the fastest interconnect we could do is 10 gig Ethernet. So the 100 gig switches will increase tenfold our bandwidth if we're able to implement that between that. And then this coming fall, we have another building coming along that will have post facilities as well. So the challenge will be all 3 of those buildings need to operate as a single unit and be interconnected in the fastest way possible. And the design of our curriculum is for students to collaborate together. So the digital arts students work and do visual effects on a film that was made by the film students. So the film students editing in one building, the visual effects artist is working in the opposite building. We want them to have real-time access to the footage to work in the fastest way possible, which is also the way the industry is going. And in the industry, it's even a greater need because people are starting to look at, I want to work with the best artists possible. That artist might be in Los Angeles, or they might be in Germany, or they might be in China, Asia. And so the fastest way to get things back and forth to enable real-time collaboration is really where the industry's headed.
Last question, Dan. So what future filmmaking technologies are going to affect our networking business?
Well, I think probably the single greatest, future technology that is coming down the pipe that's really hot right now is just actually last week at the National Association of Broadcasters Conference in Las Vegas, and there's a lot of heat around what's called virtual reality. And so virtual reality is an immersive technology where people put on an Oculus Rift headset or something similar to that, and they can look 360 degrees, and it might be travel and tourism, it might be gaming, it might be a narrative film that's being created, but they have a real bottleneck in terms of data because to do virtual reality, it requires at a minimum like 6 cameras. So you've got top and bottom, and you're getting 360 degrees. And in the end, the display is being put on someone's face, so the distance to the eye is very small. The current generation of technology, the resolution is not that good, so it's not as immersive as it could be, and so that's slowing adoption. So the industry is making the jump to 4K as well, and when we're talking about 4K for narrative, we're thinking a single stream, maybe 2 streams for a stereoscopic. When you're talking about VR, you're talking, well, the minimum is 6 cameras. I've seen rigs 12, 24 cameras, all of those shooting 4K. There could be a huge amount of storage necessary to hold it, as well as bandwidth to, once you stitch it all together, play it back. The other technology we saw that was introduced at NAB that also has a really high data-intensive application is the Litro camera, which is a light field camera. And this is a pretty unique camera, but it has great application for production because it captures a 3D space and allows you to set focus later. And so what this does for the industry is allow them to go out and do in the field what they used to have to do in a studio. So on a major film, instead of going to a green screen, they can go shoot with this camera and then key elements out. But the cost of that is, this is a 758 megapixel camera, and it records an enormous amount of data. And so to realize that savings of studio, you're going to have a lot of storage and a way to push it very quickly.
Justin, want to add anything about VR and light field camera?
No, Dan covered those two pretty well. I would say the other thing that would affect sort of network infrastructure is moving from my data rate example of 1.2 gigabyte per second for a 4K stream is based on a 10-bit DPX file format. Well, there's probably going to be a push to move to like a 16-bit OpenEXR file format, which just increases data rate there as well. So, yeah, for high dynamic range imagery and just changing the mastering format itself to a higher bitrate format will affect data rates in significant way as well. Sure.
Okay, guys. Thanks for joining us, and good luck in the future.